On this problem, we're going to find the first and second derivative using implicit differentiation. And remember, this is the derivative of y with respect to x. So we're respecting x. So when we differentiate y, it gets that that symbol, that factor of dy dx attached to it, but not when we differentiate x. So let's take a look. 6 square roots of y, that's the same thing as the square root of y is the same thing as the 1/2 power. So 6 times 1/2 y to the negative 1/2. And since we differentiated y, it gets that factor of dy dx behind it. Okay, and then the derivative of x is just 1. The derivative of negative y is 1, but again, it gets that symbol of dy dx behind it. So this cleans up a little bit to be 3y to the negative 1/2 dy dx. I'm going to go ahead and move the 1 dy dx over to the left side. I'm going to now factor out dy dx so that we can get dy dx by itself. And we're going to divide both sides by 3y to the negative 1/2 plus 1, because we want dy dx again by itself. Okay, so now finding the second derivative. And actually, I think I'm going to leave that y to the negative 1/2 power. So the second derivative, we're dealing with a quotient rule here. That quotient rule being the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So the denominator 3y to the negative 1/2 plus 1 times the derivative of the numerator, so 0, minus 1 times the derivative of the denominator. So the derivative of 3y to the negative 1/2 power will be, we'll say 3 times negative 1/2, so negative 3 halves y to the negative 1/2 minus 1, so that would be negative 3 halves power. Since you differentiated y, it gets a factor of dy dx behind it. And then the derivative of 1 is 0. All over the denominator squared. So 3y to the negative 1/2 plus 1 squared. This becomes positive 3 over 2 y to the negative 3 halves dy dx all over 3y to the negative 1/2 plus 1 squared. And we have one more thing to do. We're going to plug in what dy dx is. right here because we know what dy dx is. We found it when we found the first derivative. So 3/2 y to the negative 3/2 times and I will write that as basically, let's see, I was going to try to do this all in one step, but I better not. Let me make a fraction in the numerator, just one fraction. Okay, and so in the denominator of the denominator, well, just the plain old denominator, we still have that 3 negative 1/2 power plus 1 squared. Okay, so I want you to remember something from algebra that, if you have a fraction divided, a fraction within the fraction, so a fraction in that numerator, that denominator can come into the main denominator. So what's going to happen here is the 2y to the 3/2 and this will be in the denominator. So that's going to be 1 power and 2 more powers to give us a 3rd power. And all we have left in the numerator is 3. And this is our second derivative using implicit differentiation.